These notes are over L'Hopital's rule. But first we need to talk about indeterminate forms. There are 7 indeterminate forms: 0 divided by 0, infinity divided by infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, infinity to the 0, and 0 times infinity. Now the only 2 that we're going to see on our AP test are these first 2. And when we are trying to find a limit and we end up with a rational answer, result, 0 divided by 0 or infinity divided by infinity, we can apply L'Hopital's rule. And just an FYI, 0 to the 0 is not equal to 1, and neither is infinity to the 0 is equal to 1. An indeterminate form has no numeric value. And then 2 other things just to keep in mind: whenever you have your numerator approaching or is a constant and your denominator approaches infinity, the limit is 0. And if your numerator is approaching infinity and your denominator is a constant, then the result is infinity. So here's the definition. It says, given that you have a limit as x approaches a of f of x over g of x, and if the limit as x approaches a of the numerator is equal to 0 and the denominator equal to 0, then we can apply L'Hopital's rule, which states that we can find the derivative of the numerator and the denominator, then apply the limit. First though, let's always try substitution. Oh, and here's the other case. If the limit as x approaches a of the numerator is equal to infinity and the limit as x approaches a of the denominator equals infinity, then we can apply L'Hopital's rule, which says we can take the derivative of the numerator and the denominator and then apply the limit. Let's take a look at an example. Here's the first one. So right away, when I see the limit as x approaches 0, if I'm going to have it if it's just going to be an x in the denominator, I know I can't divide by 0. So then I've got to check the numerator. All right, so let's see. The limit as x approaches 0 of the numerator, well, that's going to give me the square root of 1 minus 1, which equals 0. Now, if you're going to use L'Hopital's rule, you have to state both that the limit of the numerator equals 0 and the limit of the denominator is equal to 0. And if this is the case, therefore, L'Hopital's rule applies, and you have to write out this justification. So what we need to do now is find the derivative of the numerator and the derivative of the denominator, and then apply L'Hopital's rule. So let's see, I'm going to go ahead and find the derivative of the numerator. So I'm going to rewrite the numerator like this. All right, so now the derivative of the numerator would be what? 1/2, 1 plus x to the negative 1/2. And then of course the derivative of this constant, 0. So here's my derivative of my numerator. Now the derivative of the denominator is just x. So the derivative of the denominator is just going to be 1. All right, so anyway, this is just kind of my scratch work off to the side. All right, so let's get back to our problem. We can say the limit as x approaches 0 now of my new numerator. Let's see what this is. And if I substitute in 0, this would give me 1/2 times 1 plus 0 to the negative half. Well, anything, 1 to anything is going to just give you 1. And so the numerator just equals to 2. I'm sorry, 1/2. And of course the denominator, it's a constant. So divided by 1, I guess I could have just put that all. So that's just 1/2. And that's my answer. Okay, so just a reminder, when you're taking your AP exam, you must, or your exam for this unit, you must write these out separately. You cannot just write out that they equal 0 over 0, because 0 over 0 is an indeterminate form. Okay, so let's take a look at another example. Here's this one. So right away I can see if I'm going to plug in 0, that's going to be 0 in the denominator. So let's test both the numerator and the denominator. So the limit as x approaches 0 of the numerator all right, so let's see, this is going to give me 1 plus 0 is, well, 1, and the square root of that is 1, minus 1 is 0, and this is all 0, so this is equal to 0. And the limit as x approaches 0 of x squared is also to equal 0. Therefore, L'Hopital's rule applies. All right, so my scratch work on this side, let's do the derivative. So 1 plus x to the 1/2 minus 1 minus, and I'm going to write that as 1/2 x. All right, and the derivative of this is going to equal 1/2, 1 plus x to the negative 1/2. The derivative of the constant is 0. The derivative of this term is just negative 1/2. And then the derivative of the denominator is equal to just 2x. All right, so there's my derivatives. Okay, so then back to my problem. So the limit as x approaches 0 of 1/2, 1 plus x to the negative 1/2 minus 1/2. And let's see, if I substitute in 0, that's 1. Okay, that's still going to give me 0. Okay, and let's check the denominator. The limit as x approaches 0 of 2x, well, that also equals 0 if you substitute in 0, 2 times 0. Therefore, L'Hopital's rule applies again. At most, I've seen you have to apply L'Hopital's rule 3 times. I've never seen a problem where it's more than that, but just know that, you know, it might happen. All right, so let's take the derivative again. And so the limit, I think I can do this one without writing out, maybe. So that's going to give you negative 1/4, 1 plus x, and if I subtract 2/2, so that's negative 3/2. And then the derivative of this constant would just be 0, it would go away. So using the power rule, that gives me the negative 1/4. Here's the inside stuff. Raised to the subtract 1, so that would be negative 3/2, and then the derivative of the inside stuff is just 1, so that's it. So if I substitute in 0 here, what does this equal? Well, that gives me 1 times negative 4th, so that's just negative 4th. Okay, and now the derivative of the denominator, if I take the derivative of 2x, that's just 2. So that's just over 2. All right, so I'm going to keep the numerator, change it to multiplication, flip the denominator, and that gives me negative 1/8. And there is the limit as x approaches 0 of this function. You continue to apply L'Hopital's rule as long as you get 0 divided by 0 or infinity over infinity. All right, how about this one? A little trig involved. So we have the limit as x approaches pi over 2 of secant x divided by 1 plus tangent x. I can't tell just by looking at this, so I'm going to actually have to just do the work. So limit, and since this is in the L'Hopital notes section, I'm going to assume that this is going to equal either 0 over 0 or infinity over infinity. So let's just see. Okay, so if I substitute in pi over 2, and I got to think about my unit circle. I'm going to draw me a quick little unit circle. Oh, that's terrible. Try that. Oh, well, that's still terrible. Okay, anyway, so here's pi over 2. And I know that the coordinate there is 0, 1. And secant is the reciprocal of cosine. And of course, cosine is the x. So that would give me, well, let's see, this would be secant pi over 2. And this is as the x is approaching pi over 2. So we need to think about this. This is going to be 1 over cosine pi over 2. As x is approaching pi over 2, if we think about this, our x values, they are getting smaller and smaller. You know, at the most they're a 1. And then here you have square root 3 over 2 and square root 2 over 2. And then you have 1/2. So this denominator is getting smaller and smaller. So if you have something, a constant, over a number that's approaching a very small, smaller, you know, this is actually going to approach infinity. Okay, let's just think about that. So if I have 1 over 10, that's 1/10, and then I have 1 over 1, that's equal to 1. 1 over 1/10, 1 divided by 1 over 10, that equals 10. You see how my value is getting larger? If I have 1 over 1/100th, that's 1 over 1 over 100. Now I'm up to 100. Do you see how this is actually increasing in value? So this is actually going towards infinity. I know, crazy. All right, so now let's take a look at the denominator. So we have the limit as x approaches pi over 2 of 1 plus tangent x. All right, so if I'm thinking I'm getting infinity in the numerator, I'm probably going to be getting infinity in the denominator. Let's just check this. All right, so this is going to be 1 plus tangent pi over 2, and tangent is the y over the x, the y divided by the x, the y value divided by the x value. And the y value is getting closer and closer to 1, and the x value is getting smaller and smaller and smaller, which is the same case that we had up here. This guy is also going to approach infinity. All right, so we're going to just plug in the word and. The limit of the numerator approaches infinity, and the limit of the denominator approaches infinity. Therefore, L'Hopital's rule applies. All right, so now we're going to take the derivative of the numerator. All right, so I got to think about this. Secant, tan. So the derivative of secant is secant tangent. So the limit as x approaches pi over 2 of secant tangent is equal to, all right, so secant is the reciprocal of cosine. And, well, I'm going to hold on. Let's just take a look at the denominator real quick, because let's just see. All right, so the derivative of the denominator, well, the derivative of 1 is, a constant is 0. Derivative of tangent is secant squared. That's what's going to save me. So that's going to be over secant squared x, because now, look, we've got a secant in the numerator and the denominator. And so this is the limit as x approaches pi over 2 of tangent divided by secant. And tangent is sine over cosine. And secant is 1 over cosine. And so keep the numerator, change it to multiplication, and flip the denominator. Holy moly, this is the limit as x approaches pi over 2 of sine x. And what is sine approaching as x gets closer to pi over 2? 1. That's pretty fun. All right, let's try another one. How about this guy? So multiple choice, the limit as x approaches 1. All right, so I'm just thinking in the numerator, that's going to give me 0. The y value at pi is 0 also. So I'm going to go ahead and state. And on this one, you don't have to because it's multiple choice, but just the limit as x approaches 1 of x squared minus 1 over sine pi x is equal to 0 over 0. Therefore, L'Hopital's rule applies. All right, and so let's take the derivative of the numerator, the limit as x approaches 1 Oh gosh, look, I would have missed this. I would have gotten 0 points on this because you cannot say that. You have to separate them out. Thank goodness it's a multiple choice, and I would not have missed the point. But anyway, don't do what I just did. All right, so don't. You have to separate out the numerator and the denominator. Okay, so anyway, I'm going to just try to finish this up. All right, so the limit as the numerator, derivative of the numerator, and the derivative of the denominator. The derivative of the denominator is what? Cosine and pi x times pi times the derivative of the inside function. Sine is cosine. And now as we approach 1 is equal to 2 over, if I plug in a 1 cosine, the x value at pi is 1. Oh, hold on. How about negative 1 times pi? How about negative pi? And so I'm going with B. And thank goodness it was not a multiple choice, because I would have missed if I would have justified it this way. All right, another multiple choice. Let's see if I can get this one right. So just thinking about this, let's see. Tangent of 0. Okay, so I've got to circle. Here's 0. That's 1, 0. Tangent sine over cosine would be 0, right? So my numerator is already telling me 0. Let's just see what's going on in the denominator. As x approaches 3, e to the 0 would be 1. 3 minus 3 is 0 also. So I've got to, and I'm going to justify correctly this time. The limit as x approaches 3 of tangent x minus 3 is equal to 0, and the limit as x approaches 3 of 3 to the e to the x minus 3 minus x is equal to 0. Therefore, L'Hopital's rule applies. All right, so now I need to do the derivative of the numerator and the denominator. The limit as x approaches 3. Tangent, let's see, secant tangent is secant tangent. No, I'm sorry, secant squared. Secant squared x minus 3 times derivative of the inside stuff, so that's 1. Easy. And derivative of the denominator would be, well, that's e. Derivative of the inside function would be 1. So I'm just going to leave that. And the derivative of x is 1. All right, so now let's plug in 3. And this is going to be secant squared 3 minus 3, so that's 0. All right, so cosine is 1. The reciprocal of 1 is 1. So this is just 1. Okay, so cosine is reciprocal of secant. And so at 0, I would look at the cosine value and just reciprocate that. And so the reciprocal of 1 is just 1. So that's my numerator. All right, so now the denominator, 3e to the 0 minus 1. Well, e to the 0 is 1 times 3 is just 3 minus 1, and that's 2. Let's see, that's 1/2. That would be C. All right, here's another one. The limit as x approaches 0. Oh, we got some natural log in here. So let's just, I'm assuming this is going to be L'Hopital's rule. Cosine x minus e to the x. All right, so let's think about this. What is cosine? Cosine of 0 minus e to the 0. Well, the x value at 0 is 1 minus e to the 0, so this would be 0. And let's check the denominator, the limit as x approaches 0 of natural log of 1 plus a 0. So, well, natural log of 1 is equal to 0. E to what exponent gives you 1? Well, e to the 0. So, therefore, L'Hopital's rule applies. Don't you love calculus when you have to remember all these other things? So much fun. All right, so therefore L'Hopital's rule applies. So let's take the derivative of the numerator and the derivative of the denominator. All right, so cosine, that would be, what, negative sign? And derivative of the inside function, of course, is 1 minus e to the x. Derivative of e to the x is just e to the x, and there's no inside function, so we're good. And natural log, that is the reciprocal function. And so now let's evaluate it. So this is negative sine of 0 minus e to the 0. And so y value at 0 is 0. E to the 0 is 1. So this is just going to be negative 1. And in the denominator, we have 1 over 1 plus 0. So that's just 1. So this is just negative 1. And our last problem, so there's a couple ways we could do this. If I saw this problem, I would not think L'Hopital's rule. I would immediately think definition of the derivative. And I would say that, well, my f of x is equal to sine x. Derivative of that is cosine x. And we can see that we have an x value of pi over 6, so f prime at pi over 6. The cosine value, at pi over 6. Okay, got a little pi over 6. So what is that? Square root 3 over 2? And done. However, it can be solved with L'Hopital's rule. So immediately, if the denominator, if we plug in 0, that's 0. So I'm assuming the numerator is going to be 0. So I'm going to go ahead and just work it out. Limit as h approaches 0 of sine pi over 6 plus h minus 1/2. All right, so what does this equal? The y value at pi over 6 is 1/2. Minus 1/2 equals 0. Okay, so and the limit as x approaches 0 of h is equal to 0. Therefore, L'Hopital's rule applies. And the derivative of the numerator, all right, so sine is cosine inside function times 1, and the derivative of the constant is just 0 divided by, and yeah, h is just the derivative would be a constant, and so the cosine at, if I substituted in 0, cosine pi over 6 plus 0, so the cosine at pi over 6 is just square root 3 over 2, and if you want to put it over 1, it's just, there it is. All right, so time to practice some L'Hopital's rule.